What's up, everybody? I wanted to take some time to kind of talk about the topic of tissues as it relates to anatomy and physiology. At this point in time in a semester, if you're talking about tissues, then more than likely you've covered cells. And I know there's a lot to talk about with cells. So if there are more topics concerning cells that you want me to, discuss and break down, please leave those suggestions in the comments below. I'll be more than happy to get into that because there's so much to talk about with cells. But once you get past cells, typically anatomy and physiology textbooks or courses like to introduce you to the topic of tissues. And the reason why is because a tissue is nothing more than a group of cells working together towards a common goal. Now, the thing that makes a tissue different from some of the other things that you learn about in anatomy and physiology and in the medical field is the fact that a tissue not only is a group of cells that come together to work together towards a common goal, but these cells are localized, right? They share some type of geography with one another in a localized space, and they typically have some type of effect either on a localized space or they create something that has an effect on other tissues and other cells in other places throughout the body. So that's something to keep in mind when you get into the study of tissues. Anyway, when you start talking about like histology and someone going in for a biopsy, right? When someone's going in for a biopsy, they're looking at a large group of cells and they want to figure out what's going on. There's something normal or there's something possibly abnormal that's happening from that mass of cells, that tissue. And so they want a tissue sample. So think of it this way. Think of a cell like a house. A cell is a house, and then a tissue is a community. Okay. So a cell is a house, a tissue is a community. And if I want to get to know about your community, if I want to know more about your neighborhood, I should be able to take a sample survey of some of the houses in your neighborhood, and that should give me a kind of an idea of what's going on in your neighborhood, right? If I take a sample of several houses out of your neighborhood, that gives me an idea of what your neighborhood is like. Whatever impacts your neighborhood should have an impact on several houses within the neighborhood. So that's why we do a biopsy, because we're now trying to figure out what this giant neighborhood is. And so we take a sample of several houses that live in the neighborhood to get an understanding of what's going on and who's creating and what and how they're being affected. So, getting back to tissues and anatomy and physiology, it's the same concept. You've got this neighborhood of cells working together towards a common goal. And so, if we want to understand what that tissue, that neighborhood is responsible for doing, we need to understand the cells that exist in that neighborhood. So, when we talk about tissues in anatomy and physiology, we usually start off with four categories of tissues: epithelial tissue, connective tissue, and muscular tissue, and nervous tissue. Epithelial, connective, muscular, and nervous. From the easiest to the more difficult, I would probably say that the nervous tissue is probably the easiest one to learn at the beginning because it's just one cell. Like if we're going to sample the houses are practically, they're not identical per se, because when you get to the chapter on the nervous tissue, you learn that there's different types of nerve cells. They're called neurons. But in all honesty, they really all are following one generic rule, and that's communication, right? When you look at nervous tissue, it's made up of neurons, nerve cells, and everybody there is about communication. They are all about communicating either with another neuron or communicating with another target cell. That's it. So if I show you a sample of nervous tissue, the first thing you're going to notice about it is that there's nerve cells there, these little neurons. And then you're going to also notice there's not much of anything else that's there either. Nervous tissue is pretty simple, pretty basic when you talk about it as a tissue. When you say what's in its neighborhood, the houses are identical. And if they're not identical, they're almost all look alike for that particular neighborhood. Do you have different types of neurons? Yes, you do. Are they of different structure and shape? Yes, they are. Do they all pretty much do the same thing? Pretty much. They are communicating. That's what they do. So that's nervous tissue. Muscular tissue, they got one primary job. That's movement. That's it. They're performing some type of movement. When you get into the muscular system chapter, are they going to add extra functions? Sure. They're going to add extra functions because there's like side, your muscle tissue when it does different things, there's like byproducts of what it does. Like muscle tissue produces heat. So it helps to keep the body warm. Yay. But really, honestly, how did it produce that heat? It didn't just produce the heat by hitting a button and turning the thermostat up. That's not how it worked. It produced heat because it moved, right? The claim to fame to muscle tissue is that its muscle cells can do something called contraction. They can shorten in length. And when they shorten in length, they move. And when they move, you move just like that. I call that the law of ludicrous. For those of you who have no idea what I'm talking about, go to YouTube, um, pull up songs by the rapper Ludacris, and you're bound to find a song where the chorus says, "When I move, you move," just like that, right? So I based this law of Ludacris based on that. Shout outs to Luda. For those of you from ATL, you used to know him as Chris Lover Lover before he became Ludacris. Little known fact. But yeah, so muscle cells, they contract, they shorten. They have the ability to shorten like an accordion. They have the ability to shorten in length. The reason why it works that way is because a muscle cell, from end to end, it's attached to something else. So you have three types of muscle cells based on what it wants to move. So you have cardiac muscle cells. Based on the name cardiac, you can kind of guess where he's located. Cardiac muscle cells are located in one place in your body, and that is the heart. Henceforth, the name cardiac. So when cardiac muscle cells contract, they shorten and they help your heart contract. And when your heart contracts, it squeezes, right? And it's squeezing because it's pumping blood. So it squeezes, it moves something, it's moving your heart. The second type of second type, I almost jumped ahead. The second type of muscle cell that creates a type of muscle tissue is smooth muscle tissue. Smooth muscle tissue looks totally different from the other two. When it contracts, it's pretty much attached to itself. So when it contracts, it makes these wave-like contractions that causes it to squeeze, and it makes a wave-like movement. And this wave-like movement is why you find smooth muscle in hollow organs. So you find it in the stomach, you find it in your blood vessels, you find it in things like the small and large intestine, because when smooth muscle squeezes, it wants to make a wave-like movement. It's like this. And so it's making a wave-like movement because that pattern is necessary. If it's in something like the small and large intestine, it makes a wave-like motion so that it can move things through the pipe. So it's moving things through versus the stomach. It makes wave-like contractions so that it can mix things up in your stomach. That's why after a really good meal, sometimes it feels like when your stomach is adding to the digestive process of whatever you ate, sometimes it feels like your stomach is moving. It is. That's a smooth muscle in your stomach contracting, but it's making waves. So instead of the pumping motion of cardiac muscle or the pulling motion of skeletal muscle, smooth muscle makes a wave-like contraction that helps to mix the food up in your stomach to help it break down. And then the third type of muscle tissue that you have, which is because it has a different type of muscle cell, is skeletal muscle. And skeletal muscle gets like a whole chapter by itself in most anatomy and physiology classes. Skeletal muscle has one end attached to an origin and the other end attached to an insertion. So basically, the origin point usually is the part that's not moving, and then the insertion point is usually the part that is moving. Don't come for me in the comments, those of you who deal with musculoskeletal anatomy. I already know that is not true for all muscles. Some muscles even switch their insertion and origins around. We'll talk about that in the future. But skeletal muscle is claimed to fame is it contracts, it shortens in length, and one end is attached to the thing that you want to move, while the other end is attached to something to act like an anchor. So when it contracts, it moves something. So most of the muscles you learn about in the average anatomy and physiology class is talking about skeletal muscle that attaches to bones. So you wind up having one end of the bone, one end of the muscle that doesn't move, and then the other end of the muscle is attached to a bone that it wants to move. And so when the muscle contracts, it pulls and it moves, and it pulls the bone, which it moves. And if the bone moves, you move, just like that. Law ludicrous, right? So that's 2 out of 4 tissues: nervous tissue, muscle tissue. That leaves you with the other 2 tissues, which are the ones that are way more in depth, and that's connective tissue and epithelial tissue. So connective tissue, to me, is kind of fun because connective tissue is really interesting when you take the time to learn about it. Connective tissue, its claim to fame, and this is very important. Connective tissue, it's called connective tissue because connective tissue connects something, right? It's all about connecting something. Now, the purpose of its connection can get quite diverse, but for the most part, here's what you need to remember about connective tissue. How do I know if I'm looking at connective tissue? Number one, it has a specialized cell. So it has a specialized cell, some type of cell that has a very unique job. All right, has a very unique job. Number two, connective tissue typically has some type of protein fiber in it. Those protein fibers are used as scaffolding. It's used to help build the connective tissue itself. If you damage the protein fibers in connective tissue, then if it doesn't, if you're not careful, it can turn into scarring, right? It can become scar tissue. And then the third thing about connective tissue is that not only do they have a specialized cell, not only does that tissue have protein fibers, but the third thing is that it typically has some type of matrix. In other words, the cells and the protein fibers are suspended in something. So an example of this would be blood. Believe it or not, blood is actually categorized as connective tissue. I know that sounds crazy. That is not the example you thought I was going to start off with, but I had to go there because this is the one that throws students for a loop. Blood is considered a connective tissue. Number one, it's got specialized cells. It's got red blood cells, whose specialized job is to carry oxygen and carbon dioxide. It's supposed to carry respiratory gases. That's a weird one, all right? You do not have too many cells in your body that, well, you don't have any other cells in your body that are specifically carrying gases just for you so they can transport these gases. So there's red blood cells. Another thing is that it has white blood cells who travel around in it. And then, white blood cells are responsible for the defense of the body. And we're going to talk about that when we get to immunity video. And then you have platelets, which in humans, our platelets are actually fragments of another cell, like these things called megakaryocytes. And we'll talk about that in a blood video. But actually, I have another blood video already up. If you haven't gone to look at that, definitely go to the playlist and check out that video on blood. As a matter of fact, don't forget if this video is helping you to like and share this video with other friends and other students, and don't forget to subscribe. But yeah, you've got platelets in like my dog. Platelets are actual real cells, but in humans these are like fragmented pieces of cells, so they're not alive. They're more like sandbags that your body uses to create blood clots. And then you have these protein fibers in your blood called fibrinogen. So these protein fibers are what you use to help make a blood clot. And when you create a full solidified blood clot, guess what? It makes connective tissue that blocks the hole that keep you from bleeding, right? So that's why it's a type of connective tissue. Another simple type of connective tissue is loose connective tissue or areolar connective tissue. Loose connective tissue or areolar connective tissue has specialized cells in it. It has fibroblasts, and fibroblasts are fiber building cells. They're immature cells. When cells have blast in their name, that usually means immature, but blast also means to build. So it's an immature building cell. Fibro means fiber, so it's an immature fiber building cell. And fibroblasts are the specialized cells that you see on the scene. They create special types of protein fibers like collagen and elastin, right? So you have these elastic fibers and you have these collagen fibers. Elastic fibers are there to give you durability, but to allow it to be able to have some type of stretch capability. And then collagen gives it strength. So you have some type of rigidity, right? So you usually see things like loose connective tissue in between the layers of your skin. It's the second layer of your skin. And that is there to attach the superficial or the top layer of your skin to the rest of your body. Like without loose connective tissue, you wouldn't have anything attaching the top layer of your skin, the superficial part of your skin, to the rest of your body, and you'd be in a world of hurt. Um, so that's loose connective tissue. The matrix that it's suspended in is, if you've ever scraped your knee and you looked at your knee and you were like, what is this gooey, this aqueous gooey substance? That's the matrix of your loose connective tissue. It's actually almost gooey aqueous type uh, um, substance that's there, that's in the loose connective tissue that everything is suspended in. So that matrix is kind of like if you were looking at a bowl of cereal. The cereal itself would be the pieces of cereal would be the fibroblasts and the protein fibers, but the milk would be the matrix. It's what everything is suspended in, right? So those are a couple of examples of connective tissue. You have a lot of different types of connective tissue. And so you kind of have to break them down one by one. You have 3 different types of cartilage. All of your cartilage is considered a type of connective tissues because they connect different things. You've got cartilage that connects the vertebrae in your back. You've got cartilage that connects the joints in your knees and your elbows. You've got a lot of different cartilage. You got cartilage that attaches the skin to the rest of your bones in your face. Like, you got different types of cartilage. You got different types of connective tissue that connect things to other things. They just happen to fall under the rule of connective tissue, which is they give you a specialized cell, um, uh, um, some type of protein fibers in it, and all of it suspended in a specific type of matrix. Then that leaves you the last type of tissue, which is epithelial tissue. And I would say that when people have trouble with the tissues, they have trouble with connective tissue, but I think they spend so much time trying to memorize nervous tissue and muscle tissue and some of the connective tissue that they mess up on the epithelial tissue. And then they get really mad that they messed up on the epithelial tissue, because epithelial tissue at the end of the day is nowhere near as difficult as connective tissue. But they mess up on epithelial tissue because there's some basics to epithelial tissue. And if you ignore those basics, you'll just miss everything on a test about epithelial tissue. And here's what I mean. The job of epithelial tissue is to cover and protect. Like, that is the primary role of epithelial tissue. It is to cover and protect. Its jobs and its functions are nowhere near as dynamic as the other 3 tissues. So the other 3 tissues, you can spend all day studying the other 3 tissues. As a matter of fact, the other 3 tissues have future chapters in your anatomy and physiology textbooks. You see those tissues with their own debut. It's kind of like, you know, it's kind of like you got Captain America on the Avengers movies, but Captain America has his own Captain America movies, right? Black Widow, really late, still mad about that. Black Widow had her own movie, even though it did come out super late. Black Widow was in all those Avengers movies, and then she finally got her own movie, right? That's how the connective tissue, muscular tissue, and nervous tissue are. They're like in this Avengers chapter, but then they're going to have their own solo movies later. Epithelial tissue don't do that. Epithelial tissue is like it's in this movie, but it's kind of like Hawkeye. Hawkeye never got a movie. At most, Hawkeye got like a Christmas special that they call a Disney Plus television series. Yeah, we got gypped. Epithelial tissue is the same way. Epithelial tissue ain't getting no solo movie. But epithelial tissue is extremely important because even though you've got those other 3 out of 4 tissues that have these dynamic jobs, someone has to protect them and someone has to cover them. Who's that job? That job's going to be epithelial tissue. Epithelial tissue likes to protect and likes to cover, and that's extremely important. I mean, if you knew how many pathogens were just in the air by itself, if you knew how many pathogens were on a doorknob, if you knew how many pathogens were in someone's sneeze, you would not want the inside of your body exposed to any of that. That's why you have epithelial tissue. Epithelial tissue covers and protects both the outside of your body as well as the inside of your body. It's all about covering and protecting. That's why when you study the epithelial tissue, the first thing that the chapter wants to talk to you about is cells. And it wants to talk all about cells. And then as you're learning about cells, you start to realize, hey, man, there ain't nothing else here. There's nothing else here. It's just talking about cells, and there's no like protein fibers. There's no protein fibers. There's no matrix. There ain't nothing else to talk about. It's just epithelial cells. Well, that's why, because it's all about protection and covering. So you'll notice that they start off telling you about how many layers of cells that if it's one layer of cells, that it's a simple epithelial tissue. If it's 2 or more layers, it's complex, right? It's multiple layers, right? So if it's just one layer, it's just one layer. If it's 2 or more layer, it's a lot more complex. And you need to pay attention to that fact because here's the thing. If it says that it's a simple tissue, it's one layer. If it says that it's stratified, it's 2 or more layers. If it's one layer, then it's probably not meant to be very protective. It's probably meant to give really basic protection. But if it's stratified and it's a whole bunch of layers, then that means that it's meant to keep things out, right? If I came up to your house and you had no gate, no walls, you just had one door and there wasn't even a lock on the door. It was just a door, like a screen door that was wide open. That would tell me that your house, you wanted people to come in your house. There's not a lot of defense. But if I came up to your house and there was a wall there before I could drive into your yard, there was another wall, there was a moat, there were chain link fences, electric fences, barbed wire, attack dogs, laser guided missiles. I mean, you just had everything, all these layers of defense there before I could get to your front door. That would tell me, nah, you don't want everybody up in your house. Okay. So that's important as well. That tells me that this is all about defense. This is all about keeping random things out. And that's the way epithelial tissue works. It's like if it says it's simple, then the next question for me is, what is it that you're trying to let in? Because you're obviously trying to be a bit of protection, a bit of covering, but you do want things to get in and out. If you're stratified, it is obvious you do not want things in and out. That's why when you look in places like your stomach, the initial layers of epithelial tissue, or in your mouth, especially in your mouth, the initial layers of epithelial tissue are like stratified. It's because you're putting food in your mouth and there's all types of chemicals in that food. And we don't want the mixture of everything in your mouth to damage the tissues that are on the other side of the epithelial layers. You just don't. That brings us to the other thing where the shapes of cells matter. So the flatter a cell is, squamous or squamous epithelium, the flatter a cell is, the more likely you want to be able to replace those cells rapidly and you want things to pass across the wall. If it's shaped like cuboidal, that's half and half, you might want to let some things in. Usually cuboidal cells are in places where you're trying to secrete things while providing some type of protection. Columnar cells are tall and large, and so they are there primarily for protection. Usually you're trying to protect against abrasive chemicals or activities. So I'm out of time. If you have any other questions, leave them there in the comments. We'll definitely get more into some tissues as time goes along. We'll see you next time.